Traffic congestion in construction zones is no longer just a local inconvenience. It has become a major national problem, costing society billions of dollars annually. With more and more work being done under traffic, congestion and the societal cost of construction are only going to increase. Congress addressed this issue when they wrote the Intermodal Surface Transportation Efficiency Act of 1991. ICE-T required that the Federal Highway Administration report back to them on ways to reduce congestion caused by work zones. The FHWA did report back on a number of solutions, two of which were the use of movable barriers. Movable barriers are crash-tested barriers that can be quickly moved across the roadway in a continuous, safe operation. They should not interfere with or create additional hazards to traffic as they are being moved. Their two primary functions are to provide clear delineation of the newly created travelway and to provide positive separation of traffic from the work area or from other traffic. The ability to be quickly moved changes how and when barriers can be used. The Quickchange Movable Barrier, or QMB, consists of two parts. The first part of the system consists of 1 meter long, highly reinforced segments of safety-shaped barrier. The barriers are connected by high-strength steel pins inserted through heavy steel hinges to form a continuous protective wall. The barriers have a modified T-top that acts as a lifting surface for the transfer machine. The second part is a transfer machine which can be adjusted to move barriers from 4 to 18 feet. It can be set up to move barriers from right to left for shoulder operations and from left to right for median work. When closing a lane, the machine moves in the same direction as traffic and is protected by the barrier as it is deployed. To open a lane to traffic, it moves in the opposite direction to traffic and is still protected from traffic. In reversible lane operation, the machine is set up in the median configuration and is protected in both directions by the barrier. In all cases, no additional protective equipment or personnel is needed in the lane-changing operation. The three primary uses of movable barriers are to open and close work areas safely and quickly, to reverse lanes of traffic to maintain road capacity, and to change and combine the stages of construction quickly and safely. The QMB can be used to open and close work areas on shoulders or medians. Because of their size, smaller and less intrusive equipment can be used during initial setup. Not until work is about to begin is the barrier moved out to close a lane. Consequently, the motoring public can be spared the frustration of passing by a work zone that is blocking a lane when there is no apparent work underway. Since movable barriers can be repositioned more rapidly than non-protective traffic control devices such as cones, barricades, or plastic drums, it is no longer necessary for construction crews to work without positive separation from passing traffic. This is important on high-speed roadways such as our national highway system, especially when more and more construction must be accomplished at night when work is most dangerous. When the Quickchange movable barrier is moved out, it creates a clear, hard paved staging platform the entire length of the project. This means that the contractor is no longer forced to work over non-movable barriers to deliver and remove materials. Deliveries can take place behind the barrier. Both equipment and workers can move more freely with less conflict and increased safety. It also makes it easier for workers to move from one task to another. With extra workspace available, the contractor can work the whole length of the project, use larger equipment, and accomplish multiple tasks at the same time, all of which greatly increases productivity. With a full-length platform available adjacent to the work, there is no need to stage work in short segments accessed only from the ends. Additionally, after a particular work item is completed, it does not have to be disturbed since equipment does not have to be moved across the completed work. Inspectors, supervisors, and workers have ready access to the work zone at all times. This means that problems can be identified and corrected quickly, and scheduling can be more easily managed. Better quality product, easier staging, increased and improved production are the results. In addition to opening and closing construction zones, movable barriers can be used to reverse the lanes of traffic to change the roadway to meet varying traffic demand during the course of the day. There are three main reversible lane patterns that we have identified. Expanding the number of lanes by use of existing median or shoulder can allow reversible lanes to be used on one side of the roadway while the other is shut down for work. For example, when the District of Columbia let the contract to rebuild the 6-lane I-395 in Washington, D.C., the first step was to take out the existing median and convert it into a travel lane. By using the newly created travel lane and narrowing the existing lanes, 5 lanes were still made available for traffic on one side of the roadway. Those lanes were divided by the movable concrete barrier into a 3-2 configuration that was shifted twice a day to maintain 3 lanes in the peak direction of traffic. The result was a minimal increase in the congestion while the contractor rebuilt the other side of the roadway. Another successful application of the reversible lane concept in construction has been to move the traffic from 2 parallel structures, twin bridges for example, to one structure during the construction or rehabilitation of the other. An example would be Maryland's widening project on State Route 1 through the ecologically sensitive Gunpowder Creek area just north of Baltimore. Rather than maintain the roadway at ground level, the state elected to span the valley with elevated twin bridges to carry the 6 lanes. The first of the bridges was constructed as traffic continued to use the existing roadway. Upon the completion of the first structure, the movable barrier was installed as a center divider in a 2-to-1 configuration, and all traffic was moved from the old route onto the new bridge. By moving the barrier twice a day, a normal 2 lanes of traffic were always maintained in the peak hour direction, while the old roadway was removed and the second bridge was under construction. Movable barriers can be used to temporarily separate traffic on one side of the highway while the other side is closed for work. For example, the Van Wyck Expressway is a major 6-lane arterial in New York City, carrying 180,000 cars per day. To repair and repave it in an expeditious manner, the New York DOT designed the project so that the Quickchange movable barrier was placed next to the existing median, and every night it was moved out a lane to form a divided highway on one side of the roadway. The traffic was then moved across the median to run contraflow style on this newly created divided highway. The other side of the roadway was closed to traffic, and the contractor worked the full width of the road without interference. As the morning rush hour approached, the barrier is moved back to the median and the whole roadway opened to traffic. The temporary contraflow lane concept again allows work and traffic to be conducted in 2 separate areas of the roadway while minimizing congestion. This in turn allows for more rapid completion of quality construction. The Van Wyck project was rescheduled to be completed in 1 year as opposed to the 2 years it would take using conventional methods. The ability of the Quickchange movable barrier to move quickly can greatly reduce time between stages of construction and often reduces the number of stages required. In Montreal, Canada, the Ministry of Transportation was able to combine stages during the reconstruction of the A40 highway, allowing contractors to reconstruct both outside and middle lanes at the same time. The combining of these stages allowed them to complete the rebuilding of this 6-lane elevated highway in 1 year, rather than the 3 years that they had originally anticipated. The project was completed ahead of schedule, even though they found an additional 20% of work that had to be accomplished once they got into the job. The ability of movable barriers to be rapidly moved into new configurations can be a big help when unexpected problems arise. When more serious deterioration was found on the Miller Highway in New York, it was determined that the whole work pattern had to be changed. The flexibility of the Quickchange movable barrier system allowed Yonkers Construction to restage their work, serpentining the barrier through the work area in ways that would not have been possible using conventional barriers. This allowed for the successful completion of the project. Movable barriers are a powerful tool that designers and traffic planners can use to great advantage. Continuous safe adjustment to the work area is now possible, which can help reduce congestion, improve safety, increase productivity, and provide a better quality product while maintaining good public relations. As more and more highway construction takes place under traffic, The challenge of safely and efficiently repairing or expanding them is one that we all face. The Quickchange movable barrier was specifically designed to help address these problems. When fully integrated into the planner's toolkit, it allows for highly innovative solutions to our everyday problems.